Hey everyone, so now to finish our discussion on the graphs of trigonometric functions, we are down to our last two, the graphs of cosecant and secant. So when you fold up your note sheet, this is what should be in the front, so let's go over this section first. It has pretty much the same thing as all the other ones do. Amplitude is always going to be the absolute value of A. Period is going to be 2 pi divided by B. C, so this is the one that's inside parentheses. If it's minus, you'll shift right. If it's plus, you'll shift left. And then vertical shift, this is D. This is the very last number you would see. Minus is down, plus is up. And these also, so these functions, you can see the pictures already, also have vertical asymptotes, just like tangent and cotangent. And these asymptotes are just the values of x for which the function is undefined. So if you were to go around the unit circle, for instance, at one of the 90 degrees, you usually would have the point 0, 1. But what is the reciprocal of 0? Well, that's where it's undefined. Okay, so as you can tell, they have the same basic shape. It's just kind of little, almost like parabolas, one pointing up, one pointing down. The only difference between cosecant and secant is where they start. So cosecant has a parabola pointing up right when you start at the 0, but secant is an even function, meaning that both sides of the graph are the same. So that parabola pointing up is right on the y-axis. Let's actually focus on just one, so let's focus on cosecant. And I'm going to point out what A, B, C, and D do to the graph. Okay, so remember this is the parent function. So as long as there is no number already there, A and B would be 1s. And then as for C and D, if those numbers are not already labeled, they would be 0s. So I'm going to show you how this comes up in the graph. So first of all, with A, that is almost kind of reverse amplitude. It doesn't matter where you pick. I'm just going to pick right here. This is where A shows up. So notice that that space is 1. So that's where that 1 comes in, right here. And you can do it either going up or going down. So say I were to do it here, going down. That's also 1. So that refers to A. Okay, B has more to do with the period, so this one is kind of harder to see. So I'm going to highlight here for us. Let's use this. Okay. So one period of cosecant is this area right here that I'm highlighting in blue. So it has to complete a full pattern. This is what's going to repeat over and over and over again. So it's always going to be a parabola pointing upwards, asymptote, parabola pointing downwards. That period, so that space there, is exactly 2 pi. So the fact that B is 1, 2 pi divided by 1 is still 2 pi. So that's where B comes in. This is period, so I'm going to label it with capital P. Okay, C, remember that's the one that controls left and right. So since C is 0, that means that the period is going to start right at 0. So if I'm controlling left and right, that would be the y-axis. Okay, and then D controls up and down, which is also 0. So if I'm doing up and down, that'll be going this direction. And they are also starting at the 0. So that is our midline of our function. Okay, secant is honestly pretty much exactly the same, just shifted over a little bit. So I'm going to label that one as well, but I'm going to try to go a little faster through this one. Okay, so remember, A and B, if they are not already labeled, we should take them to be 1s. And then C and D, if those are not already labeled, we should take those to be 0s. So A is the distance from the midline to either the max or min of our parabolas. So this here would be A, or here would be A. And notice for both of them, it hits at the 1. Okay, a period of this one is also 2 pi, so I'm going to highlight that area. Only this period is going to look a little bit different than cosecant. Okay, so for this one, the pattern is, so you have to think of those critical points. Starting at whatever your A value is, sorry, that's the bell. Then we would have our vertical asymptote. Then in the middle, we have our A value, but at the bottom, another vertical asymptote, and then it ends at another A value. But the point is, it still takes 2 pi to complete that pattern. So this here, period, is 2 pi, but because B is 1, we would divide by 1, which leaves it as still 2 pi. Okay, C is 0. C is the one that controls left and right. So we would look at the x-axis, left and right. So we would start at 0. So that's where C comes in. We know to start there. And then D being 0, D controls up and down. So that means we would look at the y-axis. Sorry, another bell. And look at the 0. And that becomes our midline. Okay, so those are the 2 functions that we're going to be graphing. So I have 4 examples for us. We're going to do 2 that are cosecant and 2 that are secant. Since the first 2 are going to be dealing with secant, I do want to look at this really quickly. Okay, so the period has to be parabola pointing up, parabola pointing down. It starts and it ends with a vertical asymptote and also has one right in the middle. And in between those 2 asymptotes, it has a critical point at 1 and at -1 between the second 2, and that it refers to A. Okay, so let's take a look at our examples. Okay, so our first one says identify the characteristics and graph each function. So pretty much any number I see is going to be a characteristic. So that 2, this pi over 2, and this 1. Okay, but how do they go with the characteristics? So the fact that A is 2 means that our amplitude is going to be 2. We're going to be 2 away from the midline. Here, we don't have a B. B would have been right here, but it's 1, so 2 pi over 1 is still going to be 2 pi. Phase shift is pi over 2, but because of the minus sign, that means that it's going to the right. Vertical shift is 1, but this time it's a plus sign, so that means it's going up. And asymptotes, I'm not too worried about that. We'll save that for last. So now, let's try to transfer all of this information onto our graph. So I like to work backwards. I like to start with the vertical shift first. So vertical shift is 1 up. So when I look at my graph, remember we would start from the origin. We're going 1 up. So our midline would be right there at the positive 1. Okay, so that's because of D. The next thing that we have is that we need to shift pi over 2 to the right. So on this graph, it takes 4 units to get to pi. So pi over 2 is literally half, so it would be just those 2 squares right there. Okay, so this right here is where I need to start my cycle of cosecant because it is C. Okay, B is 2 pi, so that means 2 pi away from that line. So the problem is, here's 2 pi, but since we moved 2 squares, we also need to move 2 squares here. So obviously we don't have enough graph for this. It would be somewhere kind of over here, I'm just estimating. But since I don't have enough graph for that, I'm actually going to work the other way because this graph is periodic, so technically this should be repeating over and over again. 2 pi is 4, 8 squares. So I'm just going to count 8 squares the other direction. 1, 2, 3, 4, 5, 6, 7, 8. So a cycle should begin there again. So I'm going to label this here at the bottom. That's the period of 2 pi. Okay, and then the last thing we had is amplitude is 2. So 2 away from our midline. Our midline is right here. So if I add 2, so this is d plus a. And then if I subtract 2, d minus a. So I'm just going to draw a quick line through those as well. Okay, so I have kind of my guidelines here. And hopefully you guys can see that a rectangle shape appeared right here. So I need to fit an entire cycle of cosecant in that rectangle. So I'm going to refer back to the front of the notes, just so I can refresh my memory. This right here, what I have highlighted, needs to fit in that space. So it's basically asymptote, asymptote, asymptote. So begin, end, and right in the center. So let's do that first. I'm going to use a different color. Let's use pink. So begin, end, and then right in the center. So I'm going to count. I know this is 8 squares, so center would be 4 squares. So right here, there needs to be an asymptote. Also, I can see the pattern already. It's basically every 4 squares. So I'm going to continue that for the rest of the graph until I run out of space. I think it's just enough room for one more. Okay, so those are my asymptotes. Okay, then back to my reference here. In between the first 2 asymptotes, it needs to have one of those upper reference points and a parabola pointing up. And in between the second 2, a lower reference point and a parabola pointing down. Okay, so I'm just spreading everything evenly. So since this is 4 squares, right in the middle would be 2. So I need to have that upper reference point right here and a parabola pointing up. Then between the second 2, right here would be the middle. So lower reference point, parabola pointing down. Okay, and then we're just going to repeat that over and over until we run out of space. So parabola pointing up. And then I know it would be 2 squares, so we're not going to get to see the whole parabola, but a good chunk of it like that. And then over here on this side as well, we don't get to see the whole thing, but we have a good piece of it. That's kind of hard to see. I'm going to make my lines a little thicker, or a lot thicker. This is what our graph should look like. Okay, let's look at our next one. So this time I have cosecant of 2x plus pi over 4 is, or minus 2. So let's label our characteristics. Amplitude goes with a, but there is no a, so remember that means invisible 1. Period always starts with 2 pi, but you divide by b, so we're dividing by our 2, which is just going to give us pi. Phase shift is pi over 4, but since it's a plus sign, we are going to the left. Vertical shift is 2, but since it's minus sign, we are going down. And I'm not too worried about asymptotes. Okay, so let's try to graph all of this onto our picture here. So working my way from the bottom up, vertical shift is 2 down. So starting from the center, 1, 2 down, right there. So that was because of D. Phase shift is pi over 4 to the left. So if it takes 4 squares to get to pi, pi over 4 is literally just divided by 4. So then that would be 1. So just 1 square to the left. So that's because of C. Period is just pi. So our graph is going to get kind of squished in a little bit. And like I already said, it takes 4 squares to get to pi, so I'm going to count 4 squares from our C. 1, 2, 3, 4. So period should end right there. Okay, so this part, I'm just making sure that's pi. And then amplitude is 1, so D plus A would just be 1 up. Oh, let me draw that a little straighter. Okay, and then D minus A would be 1 down. So you can see that we created a little rectangle. A cycle of cosecant needs to fit there. So starting with the asymptotes, let's do that first. I know that for cosecant, it begins with an asymptote, it ends with an asymptote, and it also has one right in the middle. So it looks like every 2 squares is going to be an asymptote. So I'm just going to go ahead and draw them all in. So this one has a lot. It's a shorter period, so a lot more breaks. Okay, then between the first 2 asymptotes, so we're still looking at my highlighted region. Between the first 2 asymptotes, it has an upper critical point and a parabola that's pointing up. So upper critical point and parabola that's pointing up. Okay, and then between the second 2, we have a lower critical point and a parabola pointing down. Okay, and then now we're just going to continue that pattern until I run out of space. So here's a parabola pointing up, making sure to hit that upper parabola pointing down. Parabola pointing up. Okay, now let me do the other side. Parabola pointing down. Okay, so just make sure that you are hitting your lines here. I was a little bit off, but okay. So that is the graph of this function. Okay, the second 2 are going to be secant. So just remember that one is a little bit different, but we're going to start off the same, and we're going to label everything that we have so far. Okay, so I'm going to go through and look at all the numbers that we have. So we have this 5/2, 1/2, and 2 pi. Now let's say what it means for our graph, what attributes they represent. So 5/2 is A, so our amplitude is going to be 5/2. And just because I know we're going to have to graph this in a little bit, as a decimal, 5/2 is 2.5. That makes it a little bit easier to picture. Okay, period is 2 pi divided by B, but for us, B is 1/2. So when you divide by a fraction, you multiply by the reciprocal. So this ends up being 4 pi. So this one's going to be really stretched out. Phase shift is 2 pi, but because it's minus, that means that it is going to the right. And in vertical shift, it doesn't have anything. So remember, if it doesn't have a D, we automatically assume it's 0. So basically none. It's not going to move up and it's not going to move down. It's going to stay right in the center. And in asymptotes, I don't really worry about. So let's try to graph as much of this as we can. So since vertical shift is 0, that means that it's going to be right on top of the x-axis. Phase shift is it's going 2 pi to the right. So luckily 2 pi is already labeled. So this is actually where I'm going to start. Then we have that the period is 4 pi. But obviously I don't have any space over here. I would have to count 4 pi from 2. 2 plus 4 is 6. So it would end at 6 pi, way over here. So since I can't go to the right, and I know that these patterns just repeat anyway, I'm going to go to the left. 4 pi. So here, starting from here, 1, 2, 3, 4. 4 pi. So basically, one period of this function is going to take basically my whole graph. So all of that because period was 4 pi. Then amplitude is 2.5. So D plus, so 0 plus 2.5 is about right there. That's D plus A. And in the other direction, D minus A. So it's about halfway, 2.5. So as you can see, this one has a longer space. See the space here? That's where we need to fit secant. Okay, so secant is a little bit different. Let's refer back to the front. Okay, secant is this one. So with this one, you don't start with an asymptote. You start at that upper critical point, half a parabola. You also end at the upper critical point and have the other half of the parabola. And right down the center, you're going to have the lower critical point with a parabola pointing down. The asymptotes, so you have to picture this area divided by 4. So that's 1, 2, 3, 4. See those 4 pieces? So the asymptotes are between the first and the second, so it'd be one section asymptote, 2 sections, and then another asymptote. Okay, so I know that's kind of a lot of information, but let's see what we can do here. So I'm going to try to divide my area into 4, which is actually pretty nice for us because it was 4 pi. See, 4 pi. So each section is going to be 1 pi, which means that I know that I have a vertical asymptote here and a vertical asymptote here. So just like I had mentioned, it's 1 piece and then 2 pieces and then 1 piece. Now, secant starts, let me get a different color. Okay, secant starts at that upper critical point and then a parabola pointing up. And then we have a tiny bit of space, so I'm going to pretend like it's going that way. It also ends with upper critical point, parabola pointing up, and then kind of finish it off. Right in the center, it has the lower critical point and a parabola pointing down. Okay, so that's our graph there. We only had room for 1 cycle this time. Okay, and then last one, 2 secant x plus 1. This one, I feel like it's going to be a little easier just because there's not as many transformations. That 2 is our A because it's right in front. Period. Oh, B is 1. It would have been in front of the x. So 2 pi divided by 1 is still 2 pi. Phase shift has to be in parentheses, but since there's nothing there, I don't have a C. So 0, it's not going to move left or right. It's going to stay in the center. And in vertical shift, I have that 1. Oops, I wrote over it, so let me erase so I can see what it said. It was a plus sign, so that means it's going to go up. Okay, so let's work backwards. Starting from the center, we're going 1 up. So we're going to start here. There is no phase shift, so it's going to start at 0, so right down the center, that's where it's going to start. Period is 2 pi, so if I'm starting from the center, I just need to go 2 pi away, so it's going to end here. So we're just making sure that that area is 2 pi. And then amplitude is 2, so you need to add the amplitude, so 2 up, and subtract the amplitude, 2 down. So now we created our little rectangle space. Hopefully you guys can see it right here. This is where that 1 cycle of secant is going to go. I'm going to start with the asymptotes. So I know that if I were to divide this by 4, so 1, 2, 3, 4, every 2 squares, there's a vertical asymptote, 1 section to the left, and then at the end, 1 section to the right. And then I'm just noticing the pattern that they're 4 squares away from each other. So I'm going to continue doing that for the rest of the graph until I run out of space. Okay, so those are my asymptotes. The other thing about this graph is it starts at the upper reference point and has a parabola pointing upwards. In the middle, it starts at the lower reference point, has a parabola pointing down, and then back to our upper reference point, parabola pointing up. But I only did exactly what is highlighted here in blue. Obviously, this parabola, it's only half, but it does continue. So I'm going to do that to the picture that we were just drawing right now. I only did half, but I'm going to continue it. Then later it would have a lower parabola, and then back to an upper parabola, and then just continue. So something like that. Okay guys, these are the graphs of cosecant and secant. So they're kind of the opposite of sine and cosine. Instead of taking the space in the middle, it's taking the space above and below those amplitude points. Make sure that you have this all written down and in your notes, because tomorrow we will be having an assignment over this whole thing.